This episode of Crash Course is brought to you by Squarespace.
So now we've come to the last of the naked eye planets in the solar system, Saturn. It's the second largest planet, but ironically, the least dense. In fact, if you could find a bathtub big enough, Saturn would float in it. But it would leave a ring.
One giant leap for mankind.
Okay, that's the oldest joke in astronomy, but it's true. Saturn is a gas giant, which means it has a thick atmosphere. Like Jupiter, it probably has a rocky core several times the mass of Earth, surrounded by layers of ice and weird metallic hydrogen. On top of all that is its atmosphere, hundreds of kilometers deep, composed mostly of hydrogen with a smaller amount of helium and a whole bunch of trace gases like methane and ammonia. Overall, its density is about 2/3 that of water. It wouldn't really float, though. Its gravity would draw in all the water from the giant bathtub. Although, actually, come to think of it, a bathtub filled with water big enough to put Saturn in would have more mass than the planet, so the water would pull Saturn in. Astronomy is fun! Saturn spins really quickly, completing a day in just 10.5 hours. Its rapid rotation and low density means it's really oblate or squished. It's 10% wider through the equator than through the poles. That's really noticeable through a telescope. When we look at Saturn, we only see its cloud tops. These clouds are mostly ammonia ices with water clouds lower down. The atmosphere is banded like Jupiter's, but the pattern is much fainter, probably due to Saturn being farther from the sun and therefore colder, as well as the atmosphere being deeper than Jupiter's too. That's not to say Saturn doesn't have storms. Oval hurricanes pop up every now and again. And in 2010, a huge storm erupted in Saturn's northern hemisphere. It was discovered by an amateur astronomer, and Cassini spacecraft pictures showed it getting so big, it literally wrapped around the planet, reaching a length of over 300,000 kilometers. Traces of it persisted for years. One of the most striking features on Saturn is a huge hexagonal vortex at its north pole. Vortices like this are common on planets. Earth and Venus have them too. That well-defined six-sided shape is pretty freaky, but it's actually a natural outcome of a spinning fluid, the air circulating in Saturn's atmosphere, which itself is in a spinning system, in this case, the planet itself. It's not that different than Earth's jet stream, but it's a lot bigger, about 20,000 kilometers across, wider than Earth. And right at its center, over Saturn's north pole, is a ridiculously beautiful storm system about 2,000 kilometers across. Wind speeds there have been clocked at 500 kilometers per hour. Saturn as a planet is of course an amazing place, but come on. When you think Saturn, you think rings. As well you should. Saturn's rings were seen by Galileo, but his telescope lacked the resolution to really figure out what they were. He thought Saturn might be 3 objects in close proximity. Some decades later, the Dutch scientist Christian Huygens correctly interpreted their appearance as a ring surrounding the planet. They're not solid. If they were, they'd get torn apart, since the inner edge would orbit the planet way faster than the outer edge. They're actually made of countless small chunks of very nearly pure water ice. Each particle orbits the planet independently. So I guess Saturn wins in the which planet has the most moons category. What really gets me about Saturn's rings is their scale. They're 250,000 kilometers across. If you put Saturn between the Earth and Moon, the rings would cover 2/3 that distance. And yet, despite their size, they're incredibly thin. They average about 10 meters thick. And no, I did not misspeak. I meant 10 meters. 10 meters. That's amazing. That's thinner to scale than a sheet of paper. Way thinner. If you shrank Saturn down to the size of a piece of paper, that paper would be 10,000 times thicker than the rings. So yeah, Saturn's rings are flat. But why? Well, that's tied to their origin, though the specifics of how they came to be aren't exactly known. One idea is that they were originally an icy moon that got disrupted by a huge collision. The shattered moon particles would have spread around Saturn, and any of them that were on a tilted orbit would quickly collide with others, and in the end that would average out all their orbits to form a flattened ring. Or maybe there was once a large moon near Saturn that was big enough to be differentiated. That means the rocky bits fell to the moon's core while the ice stayed near the surface. As it plowed through the material around the proto-Saturn, the moon's icy layer got stripped off, forming the rings. And again, that would form a very flat disk. However they formed, collisions would quickly flatten the ring out. And remember, Saturn is oblate, so as the rings formed, they would have felt a gravitational tug from Saturn's equatorial bulge, centering them right over the planet's midline. Saturn has 3 main rings, give or take. In classic imaginative astronomer fashion, they're given the names A, B, and C. in order of their discovery. B is the broadest, roughly 26,000 kilometers wide. A is outside B, while the C ring is fainter and inside the B ring. When the rings were first observed, the A and B rings were thought to be one ring, but then the Italian astronomer Giovanni Domenico Cassini discovered a gap between them, and we now call that the Cassini division. It's about 5,000 kilometers across, but it's not empty. There are quite a few very narrow rings inside of it. The gap is due to one of Saturn's moons, Mimas. If you're an ice particle in the Cassini division, you orbit Saturn twice for every one time Mimas goes around. This is called a resonance, and it means that the particles at that location get tugged repeatedly by the gravity of Mimas, which in essence yanks them out of their orbit. There are quite a few gaps in the rings caused by moons. In fact, there are hundreds of ringlets in the main rings. Even weirder, the F ring is outside the A ring and is very narrow, just a few hundred kilometers across. It's kept that way by two moons, Prometheus and Pandora, orbiting just inside and outside the ring. They tug on the ring particles in such a way that keeps them confined to very strict orbits. If a particle wanders out, the moon's gravity drags it back in. As the moons and ring particles interact, they can also create weird rippling waves in the rings. And this is really cool. When small moons orbit Saturn on slightly inclined orbits, it can create waves in the rings, tremendous vertical excursions that can reach several kilometers high. Saturn is weird, and so are its moons. I already mentioned Mimas, an icy moon that carves out the Cassini division with its gravity. It also suffered a massive impact long ago that created a single huge crater, making it look somehow familiar. But Saturn has two moons specifically you should know about. The first is Titan, a monster satellite that's actually bigger than Mercury, not that much smaller than Mars, and second in moon size ranking only to Jupiter's moon Ganymede. Titan not only has a substantial atmosphere, the only moon to have one, but it's thicker than our air on Earth. I wouldn't suggest breathing it though. It's mostly nitrogen with a smattering of methane and hydrogen. It's also 180 below 0 Celsius there. Definitely don't stick your tongue on a flagpole on Titan. Titan's atmosphere has a thick layer of haze that prevents us from seeing the surface using visible light. But using infrared and radar though, the Cassini spacecraft, which has been orbiting Saturn since 2004, is able to map the surface. It also deployed a probe named Huygens to land on Titan's surface, the first time humanity had ever landed on an outer solar system moon. What they saw was an odd world, Earth-like in some ways, and very alien in many others. Titan has wind-sculpted dunes, but they're made of hydrocarbon grains, not sand. There are hints of volcanoes that spew liquid water instead of lava. These are called cryovolcanoes, cold volcanoes, a term I love. This, together with measurements of Titan's gravitational field, have scientists thinking that Titan may have an underground ocean of liquid water. Intriguingly, Titan also has long, winding channels indicating flows of some kind of liquid on its surface. But it can't be water, it's far too cold on the surface for that. So what kind of liquid could it be? Well, Cassini also spotted quite a few flat regions near Titan's north and south poles. These have since been confirmed to be lakes of liquid methane, the first time any liquid has been seen on the surface of another world. The shorelines of the lakes appear to change over time, too, hinting very strongly that Titan has weather, driven by methane as opposed to water here on Earth. Weather, atmosphere, surface liquids, and an abundance of organic carbon-based molecules? Could there be life on Titan? The conditions there are interesting. We obviously don't know yet, but it's an exciting possibility. And it's not the only Saturnian moon scientists are looking at for signs of life. Enceladus is a smaller icy moon about 500 kilometers across, about the size of my home state of Colorado or the southern part of England. Enceladus is incredibly shiny, reflecting nearly all the light that hits it, a strong indicator it's covered in water ice. Parts of it are cratered, but other parts are very smooth, indicating some event resurfaced the moon. The surface also has an extensive series of cracks in it, much like Jupiter's moon Europa. Scientists suspected cryovolcanism, and that was confirmed quite dramatically in 2005 when Cassini spotted active geysers of water spewing from the south pole of Enceladus. The water is erupting from a series of cracks nicknamed tiger stripes and is coming from deep under the surface. Like Europa, Enceladus has an undersurface ocean kept liquid by Saturn's ferocious tides, which squeeze the moon as it orbits the planet. The plumes reach several hundred kilometers from the moon's surface, and Cassini even flew directly through the plumes and detected organic molecules. Could Enceladus be yet another harbor for life in the solar system? Again, no one knows, but I'd put it in the top 3 places to look, including Europa and Titan. It's weird, isn't it? We've always looked for planets where conditions were like conditions here on Earth, but it turns out extremely cold moons may be the best places to seek out new life. Saturn has a huge retinue of other moons too, and they're all pretty weird. Iapetus is shaped like a walnut, with a tall ridge of mountains encircling its equator. No one's quite sure how that formed. Hyperion looks like a huge piece of styrofoam that's been hit repeatedly with a BB gun. And that's not a bad analogy, since it has such a low density, it's likely to be extremely porous, like a sponge. A lot of Saturn's moons orbit the planet backwards, retrograde, similar to several moons of Jupiter. These may be captured asteroids, or even Kuiper Belt objects, giant chunks of ice that we'll learn about very soon in a future episode. All in all, Saturn has over 60 moons we've discovered so far. I want to add a personal note. When you ask astronomers or astronauts what got them started, what was the very first thing that happened to them to inspire them to do what they do, overwhelmingly they will tell you, I saw Saturn through a telescope. It's true. It's true for me. I remember my parents buying a cheap department store telescope when I was 5 or 6. Setting it up in our driveway and aiming it at Saturn. I still remember seeing Saturn in the eyepiece, a perfect jewel, the ring small but vivid and sharp. It's hard to believe it's real when you see it, and even after all these years, it's my favorite target when I'm stargazing. I'll never get tired of watching people's faces when they see it for the first time. They gasp, their eyes get wide, their mouths drop open. It's honestly one of the greatest joys of life. Saturn is the crown jewel of the solar system. It's the best kind of astronomical object. Visually stunning, artistically gorgeous, and filled to overflowing with incredible science. Today you learn that Saturn is a gas giant and has a broad set of rings made of ice particles. Moons create gaps in the rings via their gravity. Saturn has dozens of moons, including Titan, which is as big as Mercury and has a thick atmosphere, and lakes of methane, and Enceladus, which has an undersurface ocean and eruptions of water geysers. And though we don't know for sure, it's possible either or both moons may support life. Crash Course Astronomy is produced in association with PBS Digital Studios. Head on over to their channel and discover more awesome videos. This episode was written by me, Phil Plait. The script was edited by Blake DiPastino, and our consultant is Dr. Michelle Thaler. It was directed by Nicholas Jenkins, edited by Nicole Sweeney, and the graphics team is Thought Cafe.